Okay, we've been taking derivatives of transcendental functions. In the last video, we found dy dx for this problem, and we found dy dx for this problem. Now we have this one. Again, this is a very unusual looking function. Y equals the inverse secant of e to the 2x. And it is an unusual function. I don't know if this would ever arise in any practical applications, but let's see how we go about tackling this. First, you have to recall that the derivative for the inverse secant will equal 1 over, now here we're taking the inverse secant of u, and we're taking the derivative with respect to x, and that would equal 1 over the absolute value of u times the square root of u squared minus 1 times du dx. So, whatever function or whatever quantity it is that we're taking the inverse secant of, the derivative is 1 over the absolute value of that quantity times the square root of that quantity squared minus 1. Then you have to take the derivative of this quantity with respect to x. And even though this is a rather unusual function, the same formula applies, the same steps will be applied here. So, only in this case, our u is e to the 2x. So equal one over, and now here it says the absolute value of u. We don't have to put an absolute sign value after e to the 2x, because this is always positive anyway. Remember what the graph of e to the x looks like. If this is 1, it looks something like this. So it's always positive. It never quite makes it to 0. So we don't have to worry about tacking on the absolute value sign here. And it's just simply e to the 2x. This always is positive. And then it's going to be times the square root of e to the 2x squared. Of course, that's e to the 2x times e to the 2x. That's e to the 4x. So this is e to the 4x minus 1. And then we have to take the derivative du dx, so that would be d e to the 2x that derivative there. And this would just be equal to then 1 over e to the 2x times the square root of e to the 4x minus 1. And the derivative of e to the 2x, of course it is e to the 2x, times the derivative of this, which would be 2 times dx dx, or just times 2. And this will cancel. So 2 divided by the square root of 4x minus 1, that is our dy dx. So again, it's just applying the rules of what you've learned, and the answer pretty much just falls right out. So it's an unusual looking function, granted, but the same rules apply, and we apply those rules, we have no problem finding out what dy dx is. Okay, and for our last problem we have this one, y equals a times x minus 1 times e to the ax. This is ax minus 1 divided by a squared. A is just a constant. A is a constant. Okay, so dy dx. Now, here we have some function of x times e to the ax, another function of x. So when we take dy dx, we have to hold one of these constants and take the derivative. Then we hold this one the same, and we take the derivative of this one. So let's do that. We have dy dx equals, and let's hold this the same and take the derivative of this. Now, you might be thinking that here we want to take d dx of a to the x minus 1 divided by a squared. And you might be thinking, well, I guess we'll have to use the quotient rule. And you could do it that way formally, but it's not necessary. Here, this is just a constant. So all we have to do to get d dx is just take the derivative of the numerator. And that's going to be 0. And here we're going to have a times dx dx. So that is just simply going to equal a to the derivative of the numerator divided by a squared. Now, if you're not convinced of that, what we could do is, here we have ax minus 1 divided by a squared. All right, let's divide by a squared then. So we'll have x divided by a minus 1 over a squared. Now we're going to take the derivative of this. That's going to be 0, of course. And here we have x over a, so that would be 1 over a times dx dx, which is 1. So 1 over a. Here it says a over a squared, which of course equals 1 over a. So it's the same way each way. So for the first part then, we have this times this derivative, and this derivative is just 1 over a. So we have 1 over a times e to the ax. This times the derivative of this. Now we want to have plus this, and let's make some room here. And we'll be almost finished then. We have plus this, a times x minus 1 divided by a squared. Now we're keeping this the same, and we're going to take this derivative, which will be e to the ax times that derivative, which would just be a times dx dx, which is 1. So this is just times a e to the ax. And it looks like this and this will cancel. So we have dy dx will equal 1 over a times e to the ax plus, now here we have ax minus 1, this numerator, times e to the ax. This is divided by a. So let's see. Ax divided by a is just going to be x. So we have x times e to the ax minus 1 over a times e to the ax. And it looks like these are going to cancel out. So dy dx is just x times e to the ax. So y equals this, dy dx is x times e to the ax. And again, it's just applying the same rules that you've learned throughout your course here. And we tried to pick some unusual examples or examples that have unusual functions, but just to show you that you still apply the rules the same way. And if you do that, you shouldn't have any problems. So that's it for this video. Come back and join us for some more videos, and we'll try and solve some more problems.